This is our first lecture on Section 4.1, the commutative, associative, and distributive laws. Our objectives are going to be to know the commutative, associative, and distributive laws, showing how a statement is false, comparing the distributive and associative laws for multiplication, and knowing the different definitions of terms, numeric coefficients, variables, constants, and like terms, knowing what an equivalent expression is, and knowing how to simplify expressions. So we're first of all going to deal with our properties. So our first property is the commutative property. And the commutative property, what we have is movement. Commute means to move, just like we do in the Bay Area. We move from place to place. And so the commutative property works for both addition and for multiplication. So we have A plus B is the same as B plus A, or A times B is the same as B times A. We learned these as soon as we learned how to do our addition and multiplication tables, because as we kept going, we learned that we didn't have to learn the same amount of facts because we already had done some of them. For instance, 0 plus 8 is the same as 8 plus 0. So we already learned that when we learned our zeros, or 8 plus 0 we learned when we did our zeros. The same thing's true of 15 plus 7, right? 7 plus 15, those are exactly the same. Now it's actually the part C here and the part E here that we're going to be using in algebra, because we want to know that x plus 7 is the same as 7 plus x, and 8 times x is the same as x times 8. And then what we're going to do is we're going to be combining this commutative property with another property that is called our associative property. Now let's take a look here at example number 2, because this is what your book is going for, to show that subtraction and division don't have those same properties as multiplication and addition. In other words, they're not commutative. So for example number 2, we have a substitution problem, and we're going to show true statements versus false statements. So for part A, I'm going to substitute in A being 10 plus B being 2, and I'm going to be looking at that being equal to 2, which is B, plus 10, which is A. And then I'm going to simplify each side. 10 plus 2 is 12, and 2 plus 10 is also 12. And so that checks, and that's what we found out, right? Addition is indeed commutative. So addition is commutative because that makes a true statement. And then part B, we're going to see the same thing for multiplication. A is 10, and we're going to multiply that by B, which is 2. And then we're going to check that out against B, which is 2, times A, which is 10. And we're going to see 10 times 2 is 20, and 2 times 10 is 20. And yep, that's a true statement. So what we've shown is that yes, indeed, multiplication is commutative. And what we'd have to do is we'd have to do this for a bunch of values to really prove it to ourselves. And it wouldn't technically prove it even then. So the only way we can do a proof of, so to speak, is to do what we call a counterexample, and that proves that it's not true. Now in part C, we're going to see a counterexample for subtraction. So we have A, which is 10, minus B, which is 2, and that equaling, and it's really a question mark there, B, which is 2, minus A, which is 10. 10 minus 2 is 8, but 2 minus 10 is a negative 8. And you see those don't equal. This is a false statement. And so what we're showing here is that subtraction is not commutative. And we're going to be able to show the same exact thing for division. And I'm going to let you do that on your own, and you're going to show yourself that it is a false statement as well by doing A divided by B not equaling then B divided by A. And of course you're going to get a 1/5 versus a 5, right? So that will be your last example there. Now, next video we're going to learn about associative property.